Hello everyone, welcome to our session. Today we're going to explore Azure Container Apps, APIs, and Redis Cache for our ChatGPT completions. I'm Konstantinos Passadis, I'm calling from Athens, Greece. I'm working here as a solutions architect. You can find my details here in the screen. I'm also a Microsoft Azure MVP and Microsoft Certified Trainer. It's quite interesting today, our session, because I have already deployed a version of it, and I'm going to explain right away what I mean. So let's go to our action. First of all, I have already deployed the solution, meaning that we have deployed two container apps, one backend and one frontend. The actual app does a very simple thing. The user can select from a list of cities, for example, let's say Athens or Berlin or Vienna, for example, and press get info. The backend communicates with OpenAI in this version and with a storage account, I'm sorry, where we have already uploaded photos of the specific city. So the backend does two jobs. The first job is to send a prompt to the OpenAI API telling him, tell me about this city with 100 words. This is a control prompt already into our backend. And also it communicates with a blob storage that brings the relevant photo uploaded to our storage. We're going to see how we can deploy this really interesting solution. In fact, it can scale and be expanded into a tourist application for, tourist offices and that kind of use cases. I'm sure you can find a lot of use cases, but our focus here is twofold. Of course, we're going to see how we can deploy something like that, how easy it is, and we're going to compare the two versions that I'm talking about. The first version is using plain old endpoints, meaning that the front-end application is calling an endpoint in the backend. The second version, which we're going to deploy right now, is using Dapr sidecars. And I have selected this type of deployment so we can compare how fast or how different could be the user experience. There is a catch, however, we are using Redis Cache that is caching the answers. So the first time that we're going to call, for example, London, it's going to take some time. But the second time, it won't need to communicate the whole operation with the AI endpoint. And of course, the first version is OpenAI, as I told you. The second version is Azure OpenAI. So we have a complete differentiation on our variations of our deployment. Let me show you what I did to deploy this. The first version of this, I use DevOps. The reason I use DevOps is because it's one click, meaning I can send an API call to the DevOps endpoint and a post call that we can construct and set the ID of our uh, pipeline, right? Select the ID of our pipeline. You can find the ID of your pipeline. I'm sorry, here it is the system definition ID. So you can set a simple API call that you will say, okay, start this pipeline. So it is a build pipeline. We're not going to explore this API call. Let's have a quick look how we build this up. First of all, we're running a set of commands that are mandatory, especially if it is a new subscription. So we have to, let me zoom a little bit. So we are using this AZ CLI commands. We're setting the subscription. Okay, we are adding the extension container app. We are registering the provider, Microsoft app, and the namespace operational sites. If it's there, it's fine. What we are doing next? We are calling our script, right? We are going to publish our script, download it because we are using a self-hosted agent. So we are publishing the script and then we are downloading into the self-hosted agent and we are running it. And what does this script does? Let's see. It's a simple script to initialize our environment. Let's have a quick look at container apps via DevOps. I have chosen this, which is a little bit more transparent. So the script is setting a set of variables. We are using also a set of other variables. We're going to see them in the next steps. I'm setting the keys, the subscriptions. I'm logging in with the service principal from the script. I'm creating a random name for our storage account. I'm creating the container for the storage account. I'm creating the Redis cache, and I'm exporting the key. The password for the Redis cache is going to be used later. And we are creating also a container registry that will hold our images, our container images, and we are creating also a container app environment. This is what our first step does, right? So it publishes the script for the pipeline, it downloads it into the agent, and the agent then runs the script. Next, we are publishing the images, the pictures of the cities, right? We have the pictures into our repo here in DevOps. We are downloading the images into our self-hosted agent, and then we are running a CLI script. It is an inline script that I think it's very easy to construct. Let me see if I can, no. Okay, and yeah, the script is just uploading the images found from the repo to the agent and then to our storage blob, right? Next, we are using a managed identity. We're using a user-assigned managed identity, and we are creating it, right? We are getting the principal ID and the ID of the identity. Then we are setting this saving this variable, and we are assigning two roles, SCR pull and SCR push to the managed identity. I have also added the role Container Registry Repository Reader. I did this because I saw some errors. Maybe it's not needed, but just to be safe, I have also added this role. I'm publishing again. We're publishing our artifacts again, and this time our artifacts are the actual image. So we're publishing the image, we're downloading it, and then we're starting to build it. Let's have a quick look. What do we mean? We're publishing this folder, right? It contains all our code for the backend. And it means that we have a Docker ignore file, so we can ignore some files. For example, if we had a virtual environment or if we had a Node.js app, it's good to be consistent and always have in place these files. In our case, it's not needed. We're using the main Python file. We're using Flask for our application. It's very simple backend, as you can see. It's communicating with OpenAI. Everything is as set as an environment variable, as you understand. It also constructs a client for the Redis cache. It initializes the client for OpenAI, right? It's using the default Azure credentials you can see here. Blob service client, it has the role of storage blob data contributor. We're getting the city info, right? So we can bring also the image. And this is our prompt into the backend. Tell me about the city that the user has selected with 100 words. It also gets the city image from the blob storage, and it is writing the results to the Redis cache with a specific duration of 24 hours for caching. So we're emptying also the cache after 24 hours. This is our backend. I had a script also, but I chose to run it via CLI. The same applies for the frontend. You're going to see the differences now because the real difference regarding Dapr sidecar and this API call, it's here in the frontend. We don't have to do anything in the backend. So here is our frontend. It is more stylish because it is exposed to the user. The backend is not interacting with the user visually. The frontend it is, so we have a static folder that holds CSS and some images, and the template folder that holds our index. This is what we see here in our application. Our repo also has our Docker file, right? I didn't show you for the backend, but it's very similar. This Python for both our applications. Let's return to the front-end application and see it. So here you can identify the route, okay? For the root directory, it's calling the index. And if the route is the get city info, meaning the click from the user, it sends the request to the backend where we are utilizing a backend API URL variable to get the city info from the backend that you saw earlier. And we have some fallback for default images in case it didn't find it or for whatever. Also, an Ajax call for the JSON response. Everything is returning back to the frontend when the backend responds correctly. And this is our case, right? So if I ask for Berlin and say get info, the information came back very fast, as you saw, because I had already made this request and it came back from the Redis cache, right? It didn't need to go to OpenAI with a prompt and bring back the request. Everything came from the Redis cache. That's why you can see here how fast that was. So let's keep this information in place. This is our frontend, right? We have already deployed this and we are seeing how it responds. Let's make a request for a city that is not stored into the Redis cache. Let's say we're calling Rome. You can see here that it took a little bit of a time. I think the time was about 110 seconds for Rome. And also, this is the response coming from the OpenAI endpoint. Totally 291 milliseconds from the OpenAI and 110 milliseconds for the image to get back, right? Now, let's go and deploy the same pair of applications, constructing our web app, but this time we're using Dapr sidecars. Let's see how we're going to do it. It is very, very straightforward and easy to do it. I'm using a workstation in Azure and I have opened our VS Code. The same structure applies here. Let me hide this so you won't get mixed up. So we have the cities Dapr root folder, our backend, and our frontend, right? This is the backend. Again, Docker ignore, a .env file, just if you want to make local tests. Now, We're changing here two things, as I told you. The first thing is that we are not calling OpenAI, we're calling our Azure API OpenAI endpoint, and we are using the new version after V1 for Python with breaking changes. So I have made this change to the backend. You're going to see now that we have to initialize an Azure OpenAI client where it has API version declared, Azure endpoint, and API key. And when it comes to call the actual chat completion service, we have to also declare the deployment name. In our case, it is a GPT-4 deployment. Again, the message is the same. We're not changing uh, basic details. We're just changing the endpoints and how these two services communicate with each other. So let's go a little bit up and have a quick look in the backend. So this is the backend. Again, we're using Redis Cache to store and cache results coming from the AI endpoint. The front end again, it has the static file, the static folder, the template folder for visual, and the app.py, which is the main file. And here we will find the different way of calling the backend. We're using again environment variables. You're going to see that these environment variables are set into our code, and we have to set them also when we deploy our container app, right? We can do this at runtime when we deploy, when we build our um, container app into the container apps environment. Again, we have the main route that is presenting the index.html, and then it's calling the get city info endpoint, which, as you can see, it is a Dapr URL at this time. And let's have a look here. What's happening? As you can see, it doesn't communicate with a backend, right? It's communicating with a local host in the Dapr designated port, which is 3500. And it says, okay, talk to my sidecar into this port on the local application and go and find the backend service ID, right? So it's very straightforward. We just have to set the correct backend service ID. It's a name here. We can name it backend. And that's all. The two sidecars, since they are living into the same environment of container apps, and that's the beauty of container apps, you have one environment and you are serving multiple apps. So the sidecars are communicating with each other, and all you have to do is to set the correct name for your backend service ID. This is the next line where we're bringing up the response. Again, the storage account name for our the image of the city, a fallback action in case it fails. Again, the JSON response to bring back the results. That's it. Let's see a little bit of the different uh, ways that we are calling this getCityInfo endpoint. Let's go back to our, uh, I have it also here. Let me show you from here. This is the front end that we used into the DevOps environment. You can see that now in this case, we are not using Dapr, right? We are calling directly the backend API URL. And this is the URL that is created when we build our um, backend container app. This adds a level of complexity because you have to get this API URL somehow, store it in a variable, and bring it into your frontend. By using the sidecars, you don't have to worry about it. All you have to worry about is set the correct name for your sidecar calling the other service, which is the backend. It's very interesting. And to tell you the truth, it's the first time that I also used this type of deployment with sidecars. And I was amazed with the ease of deployment and how quickly. I was able to understand how it works. With one liner, you are able to call your backend. Let's start building, right? Let's start building. So I have already run the mandatory commands, which is the registration of the correct um, namespace, right? The providers. And I have also run this command. Let me show you where you can find this. Everything is also, I'm sorry, I have a little bit of my throat. And here are the commands. You will find them also in my site. I will provide the link to you at the end of this presentation. Let's set our variables. We need to set some variables here. The resource group name, the location, the environment name, the frontend and the backend names, the Azure Container Registry name, and the name for the managed identity. So let me run these commands. Run selected text, and we are setting these commands, right? We have run the extension and the provider registration, so let's move on. It's time to create our resource group. The first thing that we have to do is this. I have already logged in into my subscription, so let's run this command, and it's going to create the resource group. Yes, it is created, and we're going to verify it directly from the workstation. Let's open the portal and see what's happening. Although we can see that we have a successful response from the portal. I have to use my MFA here. Give me a moment. Right. So we have created our resource group. Let me filter to the interesting subscription. This is the one. Yeah, this is the resource group that we just created, right? Let's move on. Let's create a Redis Cache instance. It's very straightforward as well. We just need to select the location, a name for the Redis Cache, the resource group, and which SKU we are going to use, and the VM size. You can find every detail in Microsoft documentation, what this size means. It's the cheapest and smallest for our dev deployment. So I'm going to also run this and let it create this instance. It won't take that much of time. Let's go and refresh. Very soon we're going to be presented with a new Redis Cache instance. The truth is that you don't have to do anything about that instance. All you have to do is create the correct client and then uh, make your code store the results for whatever time frame you want to store them and be stored there. Let's have a quick look into the Redis instance. That's it. You can see here we have the name. We are going to export the key, right? We can also have scaling rules as well, and some private endpoints, of course, our own virtual network. Uh, Before we create it, we can do it, and access to a console. I'm not going to use anything about it. I'm going to export the key and just use it to our container apps to be able to write the data and the payload for caching. Let's move on. Now, all we have to do next is, sorry, is to create a new container registry. Give it a moment to create this container registry. Once we create the container registry, we're going to create the container app environment. You will see that it will select on its own automatically. A log analytics workspace is going to create one. So we can have logging. It is mandatory. And if we not set it, it will create it on its own. And then we're going to build our image. Important detail, you have to have Docker running, right? Or if you're using Linux, you just need the agent. Or if you're using Windows, you have to run Docker desktop, or find a way to have a Docker agent running. There are ways to do it without running the whole Docker desktop software. This is what I have done with my self-hosted agent. It's not of this discussion, but we can discuss it at some point in the future. All I will add it as a detail in a new post at cloudblogger.eu. So we're waiting for this. Let's have a quick look on how our container apps will look when we try to build them. So the first one is the backend. So we are assigning the user assigned identity and telling the container app that you're going to use this identity to communicate with the container registry. This is your name, the resource group. I'm setting minimum replicas and maximum replicas because in container apps, when you have not enabled scaling with at least one replica, your container app is scaling to 0. What does that mean? That the first time that you're going to call your container app, it will take time to bring up the revision, to bring up the actual replica. The revision, it would take time to bring up the replica. This is the correct phrasing. So if you want to weight here the advantages and disadvantages, if you have a running replica, that means that you're going to have some costs incurring for your subscription. But if this is if this is important to have immediate response to your web app, you have to apply at least one replica ready and running. If you leave it to the default, it will take down any running replicas when your container app is not used. There are scaling rules available to us, but the number one scaling rule is the minimum replicas. So if you want to have always up and running your container app, you need to select this setting. Minimum replicas set to 1. If we have time at the end, we can see that what it means to have this thing. Takes a little time here. I can start a new session, so we can move on. All right. Let me present these variables to the session so we don't have any trouble. Right, so we have done this. The Redis Cache is starting to create. So let's do this container registry deployment. Okay, we have to change the name. Maybe because I used it somewhere else. Let's add the VKP1 and run again this. Of course, we can apply randomness with Terraform. I can show you later how we can achieve this. I have already the code there and what it means to deploy container apps with Terraform. Right, let's go. So we're doing two things right now. We're deploying our container registry and we're waiting for the Redis Cache to finish. I hope this is not stuck. And I think the Redis cache is ready. I don't know why the console still thinks that it has to run. I believe it will be ready very, very soon. But we can move on, right? The next thing that we have to do is to create our container app environment. Let's go to the second session, terminal session, and let's do it. Let me change the container app name as well, just to be sure and on the safe side. I think the same code was used from the DevOps deployment. That's why it said that the name is already in use. Right? A new container app environment. Of course, everything can be done via the portal, but I'm providing you with the CLI commands that you can also automate. Number one automation, of course, for me at least, it's Terraform, right? Terraform is number one, and it is the correct, let's say, infrastructure as code tool, along with Bicep, of course. I think this should have been finished, but let's wait also for the terminal to present us with the result. So while building also our container apps environment, let's refresh here. Let's go and see it. It's of the basic plan, the cheapest one. And our repositories are here. When we build and push our images, we're going to see here two repos, one for the backend, one for the frontend. Let's see how we can do that. We need to give it a moment here to create the log analytics workspace. You can see that it's creating it on its own. It is needed for logging, and I hope it won't take also time. Let's go back to our resource group, refresh it a bit, and as we wait, let me show you what we have built again here. This is the previous. You will find the Redis cache, container apps, the container registry, the workspace, the user assigned managed identity, and the storage account, right? Yeah, the managed environment is ready. We're waiting for the Redis cache to be also created. So let's see our next step, what is going to be. Our next step is going to be the managed identity, right? Let's create a new managed identity that we're going to use for our container apps to pull the image from Container Registry. Let's do it. Perfect. Let me have a quick look here. I hope I don't have. All right. Perfect. Okay, this is our resource group. Here is our any roles yet assigned. We can assign, let's do. Yes, it is in preview, this command. I found it for in the documentation. and I think it is the correct one. So we are assigning this key, right? And it is assigned. If I go to in the user assigned selection, you will find that we have a user assigned managed identity ready. So let's return to our VS Code. I'm a little bit worried about this. Takes more than the usual, but we will see. I want to export the Redis key. Let's first export this one. Or we can build our image. Let's go and build our image. Now, we were used to create 3 commands using Docker. Docker build, Docker tag, and Docker push. With this command, azacr build, we will build our image and tag it directly to our container registry. We don't have to do anything else. This is the command azacr build, select the registry and the image. You can add the tag here. If you don't, it will add the latest on its own. It is that easy and that fast. Let's do it and see it in action. azacr build, select the registry, and this is the image. You have to be in the correct directory so it will find the Docker file. So I'm going to cd here to my backend, right? And now I can run this command to build my image directly to the container registry that we have already deployed. Let's see. And it is starting to break down our code to chunks, right? If you remember, or if you have known how Docker works, it breaks down our application to different chunks, and it is uploading these chunks into the container registry, constructing a repository for our image. You will find it here. We will find it here in the repos section. Very soon it will appear for our app. You can see that Docker is running the Python commands. That's why we saw that a notification to upgrade our pip. Let's hope that this won't take much time. I don't know if it is making sense, but we will see. We will see. Yeah, and we have our repo here into our container registry. Let me zoom in a little bit. And into the repo, we have our image with the latest tag, right? Uh, you can, of course, deploy this to a web app, or you can run your instance directly as an Azure container instance. But we have also the ability to build our image into the container apps environment that we have prepared for us. Let's see how we're going to do it. Of course, we have some steps ahead. First one, we need to save the identity ID. It is the ID of the identity as a new variable. It is needed when we try to build our app. So let's do it. Run selected text. Saving the variable of this command that is exporting the ID of the identity. Right. Let's see if we will be able to get the Redis key. We need it for our backend to be able to run correctly. I'm going to run the selected text. Let's see if we're going to get it. Okay, we got it. So probably VS Code has stuck there. I don't know. Oh, okay, it is completed. Yeah, it took some time, but it finally completed the Redis cache creation. Okay, we have also exported the Redis key. right? Because we need it into the backend, right? When we are constructing this Redis client to store our results. Now let's go and create our container app. Let's see here what we have. We have AZ container app create, right? Using the user assigned identity that is going to be used for the registry, right? I think I think I have no, everything is correct. It's going to use the user assigned identity that is already assigned into the environment app. Right. I don't think we need anything else. Let's do this. This is the command, right? Use this identity. The name of the container app is backend. In the resource group, minimum replicas is going to be 1 and maximum 3. We don't need more, but I need the minimum replicas to be 1, so my backend is always up and running. Use this environment. Use this image that's already stored into our Azure Container Registry. The target port for our backend is 5000, and here are the environment variables, right? We have a storage account with the name 009 that I haven't created. That's nice to see. So let's go and create it by hand. I was sure that I was missing something. And of course, we need to upload our images to the storage account. That doesn't mean that our application won't run, right? We have this error control in place. It won't fail, but let's do it end to end correctly. We need a container storage blob with the name cities and the photographs, the pictures of the cities, so we have a complete application as we need it. The storage account is going to be this one, and I'm going to change it for our code in North Europe. I don't think I want a primary workload. I don't know. These are new um, things into the other. Yeah, we have new stuff into this portal: primary workload and primary service. Okay, okay. What other things I have? Azure files. Okay, we're going to use blob storage, so I'm going to select this. Right. Nothing here. Nothing here. I will leave it to public access. I have to say here that we are able to, of course, change everything to use private endpoints. You know that. I don't know if we have the time to do it, but it to keep it that in mind, right? And we're going to upload our photos, our pictures into this storage account. So let's wait a bit. I have this into the workstation. Yeah, I have them. So let's go and upload them into our storage account. Let's do it correctly, right? With everything there. Okay, here is the storage account. Let's go to the data storage, containers, create a new one named cities, create, and let's go and upload our photos, our cities pictures. I think it's this one. Make it bigger. I don't remember now if we're going to use the JPEG or the PNGs, but I'm going to upload everything here just to be sure. I think anything works. If I remember correctly, anything works. Well, let's do it. Okay, yeah, these are JFIF. Okay, I can delete this one. Can delete these. They don't make sense. JFIF. They were downloaded from the web, so I can delete them and leave the JPEGs. Yeah, perfect. All we need to do now is go and change here the storage account name. I think that it was strkpv008, strkpv008. This is the correct one. So let's see again how we are creating this container app. Using the user assigned identity, it's going to be assigned to bring the image over. The image the application will be named backend. We have the same name for this variable into this resource group. Minimum and maximum replicas into the container apps environment. The image is called from the Azure Container Registry. The port is 5000 for the ingress. And these are the environment variables necessary for our deployment. Of course, we need to run these environment variables. Well, I have stored them somewhere. Don't remember where. But I need these environment variables. Let me see if I have stored them somewhere, or else we're going to provide them to the terminal. So we need this one, and this one. Let me go and find them. So we can do it by hand, right? But yeah, let's store them. I'm sure I had this somewhere. It's okay. Let's not lose time here. Let's go and add them. So what we need the Azure OpenAI endpoint. I'm going to get them all. And so let's go find this information. I'm telling you now that the endpoint is still the correct model, GPT-4. It's named after the model GPT-4. We need it in our code. So let's find the key and the endpoint. Let's take the first thing. It's going to be the key. So I need here this one to be this one. And I'm missing a T here. Let's put them into brackets. And I need also this one. Yeah, I know I have to change it. API key. Come on. OpenAI API key. And this is the endpoint. Let me bring it over. This is the endpoint, right? Perfect. And the deployment name is going to be GPT-4. This is the deployment name. So I'm going to store the now. Two variables for this terminal session. Perfect. And we can go back and see the Redis key. I think we have stored it, right? In this session. But let's be sure and store it again. The Redis key is this command. Run selected text. Yes. Perfect. The ingress is correct. So I'm selecting everything. And again, tell the terminal, go and run these commands. Let's see what will happen. It needs this CPU and memory, so let's do it. Yeah, I was sure about it, but don't worry. We need CPU 1, and memory 2. Too much, I know, but let's do it. You can see that at the end, we are querying the endpoint. So we're going to save it like the API URL for the frontend. Run selected text. Don't think it needs anything else. What does it need? It needs the user assigned. Okay, the identity ID. It's not run into this session. Let me do something else. I know that this is more complete with all the details. So let's do this. Right. It needed the identity ID. In the previous terminal session, we hadn't run this because we were waiting for the Redis Cache instance. But yeah, in the second session of the terminal, we have a more complete variable declare. We have declared the variables, all the variables. Yeah, so we got also this one, right? It is the backend API. We need also to store this variable. So let's do it. We don't have to copy it because, as you can see, we can run this command that will show the backend API, and it will save it as an API URL variable. Let me get it and run it into this specific terminal session. Let's keep this one. So it is making a request to the to Azure, and it's taking this thing that we have exported into this variable API URL. Why? Because now we're going to build our frontend that has the same details, min, max, the same things, right? The identity, the target port is different, it's 8,000. And here we have Dapr enabled, right? I will enable for the backend also. I don't think that I did it here. Yeah, I need to do it for the backend. Don't worry. It's good to see some things on the portal. Let's go do it. So we're going to enable Dapr for our backend. For the frontend, it will be directly from the CLI. So let's do this. You will see how easy it is. Really, it's amazing. So you go from the settings, you say, okay, I want to enable Dapr for my backend, and I will name it backend. And here I have to select, be careful here, the application port, not the Dapr port. It will be assigned automatically. HTTP is the protocol. You can use, of course, gRPC if you prefer to. Minor differences into the code. Enable and save. Yes. So we just enabled Dapr sidecar for our backend. Let's go back to our frontend and deploy our app. We haven't pushed it, so it's time to create also the frontend, right? Is the container app create this frontend app? But of course, we first have to build it. So let's build it. But another thing, be careful here. Be very careful here. You might end up with another image for another type of application. So you have to cd to the correct folder, in this case the frontend, because this is the Docker file for the frontend into this folder, and the azacr build command will find the Docker file into this folder and deploy the correct image for the frontend repo in Azure Container Registry and the correct image, of course. So run selected text, let you build your frontend. It won't take time. You saw that the building of container apps and container images is very, very fast. Give it a moment and return here to explore our CLI for our frontend. You saw that we didn't have these commands in the CLI for the backend. We did it by hand. But now in our frontend, we can, of course, set it as well. So you see here that we need as environment variables the backend API URL. We have already saved it, and the storage account name, right? So let's see. Remember, our code, our Dapr sidecars are going to communicate with each other. We don't need to do anything there. Let's see. Okay, our frontend is built into Azure Container Registry. Time to create our app. Storage account name, let's change it to the correct one. And we have a here. Perfect. This is, sorry, and this is the text for the front end. Let's go. Run it. I don't think it needs the CPU and the memory. It was everything about the identity that we haven't declared the variable in the session, in the terminal session. Let's see what will happen now. We have Dapr enabled for the backend. I'm going to refresh. The frontend is there. It's already built. This is the one. Let's see if Dapr is enabled. It is enabled, right? Let's go to overview. Of course, we can have custom domains here. You know that. This is our city guide app. You saw how fast it was up because we have one replica running, right? If we had 0 replicas, we should have been waiting now. I don't know what this error is. the fav icon, I don't care. Let's find some details about Rome and see what happens. And let's see how the backend will respond. I don't have the image, or for some reason, okay, I forgot to add the storage blob data contributor role, reader role. Let's do it. Let's do it to the user assigned managed identity. Let's go and add the reader role. We need a storage blob data reader. You see that the ACR pool role was assigned automatically from our CLI deployment. And let's say in the storage account, I want you to have this role, storage blob data contributor, storage blob data reader. I'm sorry, not contributor. Reader is enough because it is based on the least privilege principle, right? We don't need something like that. Let's see, get info for Berlin. Yeah, I don't know why it is asking. Okay, yeah, the correct. This is the correct thing. Berlin is here. It may need some time to bring up the images for the storage account. Let's try again. Athens, yeah. London, get info. Let's see. Let it refresh a little bit and give it some time to propagate the user assigned managed identity details for our application. We need still time, and it just needs the to propagate. But you can see how fast the Dapr deployment works, right? London. Let's see Vienna. How fast it is. It is quite faster than the simple API calls, right? And remember, we're not using OpenAI here. We are using Azure API, right? Let's give it a moment. I did assign the role, right? I didn't forget to assign it. Or I chose a different subscription. Let's see. Storage blob data contributor is what we need. I'm sorry, reader. Yeah, it has already the assignment. And let's refresh until it is able to get the role. I want you to be able to see the whole. Yeah, I think it got it. Let's make a new request. Public access is not permitted. Yeah, let's do that. The container has to be of type. You have to go here, configuration for the storage account. Everything is done via the DevOps, but through these AZCLI commands, you either have to be ready and do it or do it via Terraform. Configuration has these details. I'm adding anonymous access, and here we got the images. Let's refresh and see the response. Okay, let's go for Athens. Yeah, it didn't had to communicate with OpenAI. Everything came back from Redis Cache, right? But Lisbon, let's see Lisbon. And this is the Lisbon time that it took to bring up the whole information, right? So, in fact, we are observing 3.5 82 seconds to bring the details from the from the Azure OpenAI endpoint, and 11 milliseconds to bring the detail from the storage account. Let's go back to the other application that is not using Dapr and see what will happen. Let's see for London. London took a little bit faster, but I think that the results are already coming from uh, Redis Cache. Yeah, Athens is not cached, and it took a little bit more of a time. Yeah. So what do we have to understand here? It's not about speed. And this is a conclusion that I'm coming along with you right now. So it's not about speed, right? It's about ease of configuration and parameterization into our code. You see here how easy it is to create my client for the endpoint. I'm just saying, okay, this is Dapr URL. I don't have to know the URL of my backend. And this is very important when you want to deploy automated web apps, when you want to have to facilitate the deployment of these web apps, when you have different teams working on the backend or on the frontend, right? This is a very important use case. All you have to agree upon is how you're going to name the backend service, right? The ID is the name of the backend service, and this information is coming from this setting. If I go to my backend app and go to the settings and find the Dapr configuration, you will see here that this is the application ID that we saw into our code. Remember, the port here should be the same port the application uses. So each sidecar will uh, uh, will know which service is going to communicate with. And this is a very simple deployment, right? We're not using something advanced with Dapr. You can find more in the Microsoft documentation. We were able to see today two different deployments, one with simple API calling from the frontend to the backend, and the other one using Dapr sidecars. We understood that it doesn't make a real change regarding how fast the information will be brought upon, but it makes a difference into our code. We don't have to be aware of how the backend API is constructed or the URL is constructed. All we have to do is agree on the naming, especially if we have different teams to create the front end and the backend. Or more advanced details should come in later posts and videos. I really hope you like this video, guys. I believe the sound is much better than the previous time. Thank you very much. See you on the next time. Cheers, everybody. Bye bye.